Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 814, binary tree pruning. Given the root of a binary tree, return the same tree where every subtree not containing a 1 has been removed. A subtree of a node is node plus every node that is descendant of that node. Okay, they're asking us to find whether a subtree is full of zeros. Then we want to just ignore it, or we want to take that in our tree. Okay, let us see this example. First, see this example. See it. What is maybe subtree? A subtree is from, take for example, if this is our node, then entire nodes that are below to this, is called a subtree. So this is a subtree. Can you understand this? If I take from here, then I can say these are all what? My subtree. Hope you understand this, right? Now, what is a subtree that is containing all of 0? I can say this one subtree, this one subtree, and this one subtree. So these three subtrees are containing zeros, right? So I want to get rid of this. So just delete it. Okay, so what is our binary answer? It is 1, and its right side is 1, while left side is what? Just an empty, which is what? Just a null. Hope you understand this, right? Now, coming back to this example. Now, in this example, they are given that 1, 0, then 1, here is 0. Okay. Now, what are all the subtree? I can say this one subtree, this one subtree, this one subtree, then, this 2 are one subtree, and this 0 are one subtree, and this whole thing is one subtree, right? So, these are all the possible subtrees. Now, in this subtree, which are all containing zeros, I can say in this subtree, this is fully of 0. So, get rid of this. This is also fully of 0. Get rid of this. Okay. Consider this is our subtree, right? This is our subtree. Should I delete it? No. Why? Because here is 0, but here is what? 1. So we cannot delete it. So my final answer will be what? 1. Left side is 0. Right side is 1. Again, in down, it is again 1 for the zeros left side. Hope you understand this, right? Okay. Now, how to do this? Okay, we are focusing on what? A subtree, right? A subtree. So let us take an example. So this is our example. Let us take this our example. Now, from this example, tell me, if I am at this node, and we want to check what? We want to check whether all things that are below it are 0. All things below it are 0, right? I am here, right? So this whole subtree is 0? No, right? No. Okay. Now, perhaps. Now I go here. Now, this whole tree is a subtree containing only 0? No, right? Okay, now go here. This whole tree is, this whole subtree containing 0? No. Okay, I again go there. This whole tree containing any 0? Yes. So I want to delete it, and what should I do? I just return null here, such that it will point what? Null. I will make this address as what? Null. Okay, now again, I'll go here. Whether this whole subtree is 0? No, right? Okay, again I go here. This whole subtree is 0? Yes. So I will delete it and make this what? Null. So from this, I can say we are just at one node, and we are checking all the descendant node like a subtree, and by traversing all those, we are checking that every value is 0. If it is so, we want to delete it, right? So to do this, what's our time complexity and space density? My time complexity will be over n square. Can you understand this? We are at one node, then checking everyone, then another node, checking everyone, like that. So it will be n square. And what is my space density? It is over h, because to do this, we have DFS traversal. In this DFS traversal, you can use Pirai traversal. You can use a Pirai traversal. Okay. To use this Pirai traversal, we want a recursive stack. Yes. So that recursive stack will occupy some space. That is what? O of h, which means what? O of height. Okay, the height of this binary tree. Fine. Now, can we optimize it? Okay, we can think about it. Let us take this example again. Now, I am here, right? I am here. If the 0 is deleted, I can say I want to delete this 0, and then I don't want to go. We are here now. We are here. Now, just observe. Why we are going from top to down? Better we can go from down to top. Why? Because from bottom to up, it is easy to take the subtree, right? The subtree are where? At bottom. So let me say the approach. See here, I am at this one, right? So we are going to do a post or a traverser. Okay, now I will go here, then I will go here, then I will go to the left. Now it is what? A null. So it returns what? A null. It returns what? A null. Okay, again I will go here. Again it will return what? A null. Okay, fine. Now I found a 1 here, right? I found a 1 here. So what should I return here? Here I return, I have a node 1 in the left side. So it means what? A node 0 as node 1 in its left side. I will return it to the left side. Okay. And also, I want to give some more information, right? Because if it is like 0, 0, 0, then I should delete this whole subtree. But if it is 0, 1, here 0, then I should only delete this only 1 and 0, right? This only 1 node. So I can say, I want to confirm that in below to you, I have 1 in it. To do that, we will keep track on it. Like we can pass a list. Like we have node 1 and also we have 1 in the subtree. It may be in any of the subtree. We have 1 in it. So we will pass these 2 arguments. Can you understand this? Yes. While here it is null, right? So we will pass 0. Here also 0. You see what? We don't have any 1 below it. Okay, now again I will go here. Okay. Here also that is null. Here also null. So it passes what? In both sides it passes a null and 0. Which means what? For this 0 node, I have a null here, and there is no more zeros below it. Sorry, no more 1s below this 0. Can you understand this? Again, here it is what? 0. Okay. Now we want to check whether. See here, what are the things here we will return? Here we return a null and 0. Here also we will return what? A null and 0. So from this I can say there is no 1 below it. And also I should just get rid of this all subtree, right? If there is any 1 0, I don't want to get rid of this all subtree. But there is no 0. There is no 1. Can you understand this? If there is any 1, I don't want to get rid of this. But it is all 0. Right? That's why it is also 0. It is also 0. Left also 0. Right also 0. That means what? In left subtree, there is no 1. In right subtree, there is no 1. So I should return what? I should return a null. Don't take me as your right subtree. And also, there is no 1 below me and also me. Myself, that it's not 1 value. Right? Okay, now again. For this 0, what are the left side return value? Left side return value is node 1 is present in my left side. And also, there is 1 in your left subtree. Okay, this is what a left side. And also my right side, it is null. And there is no 1 in your right subtree. So from this I can say there is a 1 in its left subtree. So I don't want to do anything. I don't want to delete this 0, right? I don't want to delete this 0. So this 0 returns what? Here, I am a node 0. And also I have a 1 in my subtree. I don't know where, but I have a 1 in my subtree. Okay, now this one will be again go here. Right side. It will be what? Root dot right. Now, again it goes to left. In left what? It is null. So it returns what? 0, null. Sorry. Null, 0. Sorry. Null, 0. Okay. Now again it goes to right side. Now from this 0, I will go to left and right. While going to left, it returns what? Null, 0. To going right, it also returns null, 0. Okay. Now we are observing what? 0. In its left side, it returns what? A null and 0. In right side, it returns what? Null and 0. No. See here, it is also 0. It is also 0. Which means what? We don't have 1 in our left subtree. We don't have 1 in our right subtree. So I can say it should not be my answer, right? It should not be my answer. So this 0 returns what? This 0 returns, hey, I don't have any 1 in my subtree, including myself. So don't take myself. So it will be null. And also I don't have any 1. So this is the return of this 0. Okay, now this 1, we don't want to check this 1, right? We don't want to delete this 1. So I will done directly what? Okay, myself node 1. And in my subtree, and also myself is containing 1. Okay, here this is the 1, right? That's why we are returning 1. 1 as the second parameter. Sorry, second return type, return value, right? Now, from this one, now, whether it is 0 or no, right? So it is 1 only. So we can return what? We can return directly, okay, I am node 1. And myself 1, right? So I can return what? I can return, don't delete above me. Don't delete above me and don't delete myself. Okay, that's what it's written. So finally, what is our return value? It is node 1 and also 1. So which means what? Which means we don't want to delete this. Also, we want to take the root. So if I take the root, it will be what? 1, then 0, then it has a left side. But the right side becomes what? The right side becomes a null. So it is null. Then it comes here and it is what? Right side is 1 and also its right side was what? Null. Because we deleted this 0, right? We return the null here. Can you understand this? So this is what our output tree. Hope you understand this. Now, what is my time constraint space on 3? I can say my time of t will be O of n and also space of t will be O of h. Can you understand this? We are optimized, right? See here, we are only visiting each node only one time, and also there is a recursive stack while creating, traversing to each and every node in the array using a recursion, so that the space of t will be got O of height. Hope you understand. Okay, let us see the code. See here is the code. If dbus of root, if not root, then what should I do? I just return a null and also a 0. Can you understand this? A null and also a 0. Okay. If the root.left comma L is equal to what? dbus or root.left. So when I'm moving the left subtree, I want to check what? I want to get the value and I want to store it what? Root.left. Can you understand this? We have done that. It returns what? Null. Then we want to store our root.left as what? And null. And L is what? L is whether we have any one in our subtree or not. In a left subtree, especially in our left subtree, we have any one or not. Similarly for the right subtree. Now I want to check what? If root.val is equal to 0, which means what? The current value of root is 0 and also L is 0 and also R is 0. Then what it signifies? Current value is also 0. Its subtree also don't contain any one. Then that whole subtree should be deleted, right? So I will return what? And none, comma 0. Can you understand this? Now, if not, then I should return what? A root, comma 1. When we should return this root, comma 1? When my subtree, from my node to the subtree contains any one, I can say it don't be deleted. That subtree don't be deleted, right? So I will return what? Root, comma 1. Now, root, comma descendant is equal to dbus of root. Can you understand this? So, again, I will return the root at last. If, take for example, if this is my tree. If this is my tree, then this returns null. This also returns null. And this also returns what? Null. Can you understand this? And the final answer will be what? So this also returns null, right? So from this, I can say our final answer will be what? And null, which means none. So there is no more tree present there. Can you understand this? This is what our answer. Thank you. Then what is second condition? If the roots is a leaf node, then what should I return? I should return what? -1. Why we are returning the -1? See here, just take for example, if there are two roots, okay, if the root's value is equal to the child, then only it goes beyond it, right? Here also, it goes beyond it. Else, we will take that itself. So I can say, whenever there is a leaf, it returns what? -1 only. Yes. So I will return the -1. Okay, now, then I'll assign L is what? Roots left. And R is what? Roots right. Fine. Now, next step. I should check whether we want to traverse to left or traverse to right? So what is the condition for traversing? If that roots value is equal to left, which means what? We want to go beyond that, right? Just take for example, it is 1. Here it is 1. Then here it is 3. Here it is 2. Here it is 1 again. Here it is something like 3 and 4. So from this 1, we want to go to this 1. Then we go further on it, right? But here I will take this 3 and return this 3 itself, right? So that's why we are not going beyond it, right? So here we want to go beyond it. So I am take L is equal to DFS of just root dot left. That's it. So why I'm taking this L is equal to, because we may get the second minimum possible value from our left subtree, right? That's why I'm making this recursion call. Now, if the root's value is equal to right value, right side, then R is equal to DFS of roots right. That's it. Yes. Take for example, for this tree, this subtree is not going to traverse, right? Sorry, not going to recursion call. So this 3 will be directly written, right? So that's why the 3 will be where on this R itself, and this will be not executable. I understand this? Yes. Now we want to check whether the both 3's value is not equal to -1. So L is not equal to -1, and also R is not equal to -1. Can you understand this? Let us take for example, it is something like a 1, right? For 1, I say here also 1, here also 1. But here it is 1, but here it is 2. Here it is 1, here it is 3. So for this one, here it will be 2, sorry 3. Here it will be return value is what? 2. So you want to take the minimum among these 2 and 3, right? That's why I want to take what? Just return min of L and R. That's it. If L is not equal, sorry, L is equal to -1. My left is equal to -1. Then what should I return? I should return the right. If my my R is equal to -1, then what should I return? I should return L. Okay. If both of them are -1, then I should return any one of them. So it will be what? -1. So I can say this is the whole code for this approach, right? And then what's the time complexity space empty for this approach? I can say at the worst time complexity, it can be over n only. We are going to iterate each and every node. Just take for example, here 1, here 1, here 1, here also 1, here also 1, here 1, here it is 2. So we are going to iterate each and every node, right? Now what is the space empty? It is verb cuts. So these two are the time and space empty for this solution. Okay, let's see the code so that it's more clear. See here, this is a code for finding what is the smallest and the second smallest number by using what? The first approach. See here I used L, I put L, right? L is the smallest and SL is the second smallest. Okay, now float of infinity. I'm taking the int max. Now I'm going on traversing each and every node and I'm checking whether the condition is satisfied. Here I gave the condition, okay? If the condition is satisfied, I will do the operation store in what? L and SL. Okay, and I made that was enclosed variable. Both are enclosed variables, such that it will be updated like a static variable only. Now at last I will return SL if SL is not equal to float of infinity. Else I want to return what? A -1. Can you understand this? If it is a maximum number into max, then I can say it is not changed, right? So I want to return what? -1. You don't have any possibility. Let me submit it. Yes, it is submitted fully. Now let's see the second approach. Second approach is the most important approach. See if there is no root, it is not root is equal to null, just I return -1. If it is a leaf node, then return -1. When this condition is satisfied, when this condition will execute, when take for example, the root value is 2 and its child value is 2, then only this child is leaf also. This child is leaf also. Then only this condition is satisfied. That's why I am returning what? -1. Yes. Now L comma R is equal to root dot left dot value and root dot right dot value. Now if my root dot left dot value is equal to root dot value, then I will take L is equal to DFS of root dot left. Same for the root dot right also. Now if both are not equal to -1, then I should return what? Minimum amount, right? And if L is not equal to -1, I want to return L. Else I want to return what? R. Because L is not equal to -1 means I am returning L. If it is not the case, see here is what? L and R should not be what? A -1. If any one of them, which means if L is -1, then I should return what? Sorry, if R is -1, I should return what? L. If L is -1, I should return what? R. And also R is what? -1 only in another case also. So I am returning what? Just R only. Now I'm just returning what? DFS of room. Let me submit it. Yes, it is submitted successfully. Thank you.
Yeah, I'm a dog.